Hello and welcome to day 2 of Learn to Code. Today we'll be reviewing what we covered last time, as well as going over basic control statements, which are if statements, and Boolean logic, which is what you use to control if statements. And so we got a one or two people here to start with. So in the meantime, while we try to get some more people in here, I'm going to just review what we did last time. Going to hop over into my Eclipse. I did, over the past week, change it over to a dark theme, so if anyone in chat wants to go back to the light theme, just let me know, and I can do that, but I prefer a dark theme. Also added my face and stuff in here to get stuff a little more professional, but as we hear, so first thing we're going to do, we're not working on our first project anymore. So what we're going to do is we're going to right click it, go to new. We're doing a new Java project, and this is going to be day 2. Call it day 2. Yep, and everything just finished. So we can close out of what we did last week. We did our hello world, we did our compute area function, but first project we're done with. Day 2. So we're under our source directory here. We want to go to create a new class, and our first project of the day is going to be reviewing everything we've done so far, plus adding the modulus or remainder math operator. So we're going to be displaying the current time. So current time. So I'm going to call this, and we want a main. We do want a main function. So I'm going to finish. Hey Kyla, leaving the lurk. But so we got our main function, current time. So what are we going to do in this function? We are going to display the time in the console. We're going to be displaying the current time in the console. And the way we're going to do this is by invoking a new method that we haven't used before, which is system dot current time mills. LLIS. Current mills. This is the method we're going to be using to get the current milliseconds in GMT, or Greenwich Mean Time. This is pretty much showing the epoch time in milliseconds. Epoch time is the time that Unix computers use, which is how many seconds have passed since January 1st, 1970, is what epoch time is. And epoch time is one of the most standardized versions of time on the internet, because everything is pretty much synced to GMT epoch time. So that's how much this function right here will get how many milliseconds it's been since the January 1st, 1970. And let's see, we're trying to find how much time has passed. So what we're going to want to do here is we're going to want to define what our function is going to want to do. We're going to want to find all the total milliseconds, total seconds. Actually, I'm going to capitalize these. Total millis, and my capitalized second as well. Total seconds. Should be doing this in a block comment, but I'm not. We are going to do... Oh, surprise! It's Danielle. Hello. And then we're going to do total minutes. And then total hours. Actually, I'm going to leave the S off. Total hour, total minute, total sec, total millisec. Just to be consistent. So we did total hours. And then we need to find total days. Total day. And so, what we're going to do is, since milliseconds, this is going to give us a huge long string that's bigger than an int can hold. We're going to have to use a long. So the first thing we want to define is all of our time. So we want long total MILLISEC. And what you can do in Java is you can put a comma and define multiple variables at the same time that are all of the same type. So total millisecond, TOTAL, total min, total HOUR, and total day. Total day. And then you just put a semicolon at the end to end it. Now it's giving the yellow squigglies because we haven't used these. But now that we've defined all of them, we're going to set our total milliseconds. So equal to this right here, system.current_time.milliseconds. And there. So we have our total milliseconds. Now, to get seconds from milliseconds, the math function is going to be, so we got total CC equals total milliseconds divided by 1,000. It's not 1,000. That's 1,000. Divided by 1,000. And then, now is when we get to come to some new things. So we have the total amount of seconds that have passed. Actually, I don't think we're going to need total. We may need total days, we may not for this. But, now that we've found how many total seconds have passed, we need to figure out... Let's display this real quick. If we go back, I'm just going to use a... Nope. I clicked the wrong button. My bad. Click the bad macro. Go in here. This should do console. Nope, it's not console.log. It's system. So use system.out.println. That's right for Java. Console.log is for a lot of other programs. So we are going to display total seconds in the console. So I'm just going to save that and we're going to run. And you see this is the total amount of, this is what epoch time is. It's the total amount of seconds that have passed since midnight of January 1st, 1970. And so, what we're going to do with this is we're going to use the remainder function, or modulus. I'll be calling it the modulo or modulus. Both are fair game. But what we're going to do is find out how many times does 60 go into this number, and then what's left over. Because if it goes in there even amount of times, that means a minute. That correlates to a minute. We want to just get seconds. So we're going to get a, this doesn't need to be a long, this can be a int current sec equals total sec modulo 60. Because there's 60 seconds in a minute. Why is it yelling at me? Oh! Here we go. We are now going to cover something called... Yeah, do I want to cover typecasting today? Not really. So we'll just go ahead and make this a long... Typecasting is where you can cast a larger value to a smaller value. So we'll just keep them as all longs for now. But now if we do system out dot print we want to print line, and here we want to put our current seconds. So now, if we use this, it should print out. Okay, so when I ran that command, it was 18 seconds past the last minute. Can you type S out and then control space? Oh, did not know that. Thank you, Alex. That's very helpful. Let me see if that works. So that'd be standard out, control space. That is awesome. That is actually awesome. Thank you for that. Make this just go a lot quicker. But we're going to print the current second. So if we run this again, we get 2. It's 2 seconds past the last minute. So that's using the modulus operator. So now we're just going to continue along pretty much using the modulus operator. We're going to be using divide to get the total and then modulus to get the current. So if we take this and just copy it and change total seconds to total minutes, total minute, and then this to total sec, and change total sec here to total min, and get current min. Except for we don't divide by 1,000, we divide by 60, because there are 60 minutes, there's 60 seconds in a minute. So we pretty much just go along repeating this. So that gets us our current minute. Go down, do this again. This is going to be total hour. Yeah, we're not going to need total day. We're just going to need total hour. If we want a date time, we could use that, but we're just going, so this is going to be current hour. Because we don't care really what day it is. We could do day if we wanted to, but it's just going to give us a number since 1970. So what's really the point? It's, if we were using date time, then it might be useful, but not really for this application. So total hour, we need total min divided by how many minutes for an hour? There are 60 minutes in an hour. And then we change this right here to total min. No, total hour. That's right. Total hour. And so this will get our current hour, our current minute, and our current second. And this is not by 60, this is by 24, because there are 24 hours in a day, not 60 hours in a day. Boy, I wish sometimes we had 60 hours in a day, but yeah. So that is that, and then we can just go and do a nice, good old print statement. Just copy this from the handout I am using. And the current time is current hour, current minute, current second. So if we now run this, save it, and we run, say current time is 20:32:13 GMT. And this is also in 24-hour format. We could do this in 12. We could change 24 to 12 and get 12-hour format. So it's 8:32:28 GMT. So here we're minus 4 hours. So it's 4 o'clock Eastern Standard Time. But that is how you use the modulo, because it will take, if we do a copy this and print out, we're going to do the current hour. We're going to do the total hour. Total hour plus total minute plus total second here. And you can see what the modulo does. No, I did not save. So it takes this number right here and divides it by 12 as many times as it can. And then it gets the remainder of that, which is 8. Here, it does the same thing, but with 60. So if you take this number right here, let's get my calculator up. Not calendar, calculator. So if I get a calculator up here, and we do 2, 5, 9, 7, 4, 5, 1, 3, divided by 12. Nope. Nope. Where's back button? Divided by 60, we get this. So we get 0.55. So we can take this number off. Take this number, paste it, and multiply that times 60. And then we take this number minus this number here. Hold up. So we get 33. And so that is the remainder. So we get 33 as the remainder. And that is what the modulo operator does. If we look here, so we take this number and we divide it by 60. And we get the remainder, which is 33. So that's how the modulo operator works. So, next thing to cover is going to be augmented assignment operators. This is just going to, I'm just going to do this in a new class main. So a new class, and this is just going to be operator. I'm just going to call this class operator. We want this. And we're going to, and then I will pull up my sheet here. We'll blow it up for you. So I'll bring this out here. See, this is what we're going to be talking about. Augmented assignment operators. So what this does, this is the best way without me retyping it. It's taking the value I plus itself. So it's I, the I is going to equal itself plus 8. As you see right here. So I plus 8, I is now I equals I plus 8. And this is what augmented operators are. I'm just going to cover this real quickly. So just scroll down here. It's if you're going to update the value of the variable you're setting itself to, augmented operators are the way to go. It's just a shorter version of writing out x equals x divided by this is the same as x divide equals the same thing. It's just a less typing, less work. That's what it is. So that's pretty much it for that. And then next, we are going to cover increment and decrement operators. Let me find a good example of this without using loops. Increment, decrement operators, I'm actually going to save for when we cover loops, because loops are when you use those operators the most. It's either adding or subtracting a value of one value of itself. So, I think that covers it. Maybe do one more. See if I can find one more example here to do before we move on to new material. Nope, I couldn't really find one. So, today we are going to be covering if statements and Boolean logic. So an if statement, just as if you're speaking English, is if a condition happens, do this. So it's pretty much how if statements work. One sec. I will be right back. I thought I heard someone call my name. I will be right back. And I am back. So, therefore, it's just like English if statements. So, if statements are conditional. If X, then Y. So, I'm going to find a good example for this, and then we will cover... actually, first, let's cover what Boolean is. Boolean arithmetic is arithmetic of true and false, ones and zeros, as it goes in computer cases. But it is a data type, a Boolean data type is a data type that can either be true or false. They are usually used as flags in programming, so if this has happened, set it true. If it hasn't happened, set it false. It's great ways to check if things have been defined or used for error checking cases. Those are also where the flags are used. It's like, if this variable has not been assigned, then do this, and it's pretty much what controls if statements. If statements work off Boolean logic. If the conditional is true, do it. If not, skip it. So in order to use if statements, you need to understand Boolean data. And so Boolean data is anything that is a comparative. You compare things in Boolean. So if we bring this sheet back over, yeah. Oops. Come on. Bring this sheet back over here, and I will pull it up on screen now. We have Boolean data types. So, these are the 6 operators that Java uses. There is less than equal to, greater than equal to, and not equal to. Notice here the double equals. That is very, very important for Boolean logic is if you're going to compare something, you need the two equal signs. The single equal sign is a set operator. So that means the thing on the left will be set equal to the thing on the right. A double equal sign compares the value of what's on the left and the value of what's on the right. So you say this right here, double equal sign right here, is compared to this. So say this is 3 and this is 2, it would be not equal. But if they're both 3 and you use a double equal sign, then you'll get back a true. If you have a 2 over here and a 3 over here, this value will get set to the 2 because if you use a single equal sign. So that's just right here. Be very careful of that. But it all has to do with true or false. So what we're going to be doing is we're going to be using system.out.println, and we're going to be issuing Boolean expressions in this line to see what their values are. So if you back over here, we go here and we do 3 less than 1. So we're not treating it as a string. We're treating it as evaluate this expression is what we're saying. Evaluate this expression and run it. So we're going to save this and we're going to run. And it prints back false because 3 is not less than 1. But if we change this to greater than and run, it returns true. If we do equal, we're going to get an error. Watch this, we're going to get an error because 3 cannot equal 1 if you use a single equal sign. So if you see, we get the error down here. Must be a variable because it is a constant trying to be equal to a different constant. But if we stick in a double equals, it returns false because 3 is not equal to 1. These right here, these values could be variables, they could be anything. But let's say we do this, int x, and we system print x. I don't know if this is going to work. It works in other languages. Does not. Actually, if you set it to null, it will work. Can you not set it to null? Let's see if this works. Yeah, I didn't think this would work in Java. Java is a weird language, but I know in Node.js and JS you can do that to check and see if a value has, if a variable has been defined or not. It'll either return null or false. As a review from last time, null means nothing. But so let's say we have, let's go back to our first project here, and I'm just going to grab the stuff that we use for the scanner. So we're going to grab this. Import scanner, and then we want to create scanner, just so I don't have to type, but I will review it once again. So we are importing the scanner type. We're defining a new object called input, and it's of the new scanner type, and it's going to be from the system in source. So we got a new input. So if we do int x equals input dot next int, and then we do there we go, copy this, make this y, we can do x is less than y. Plus this is just a divider here that I'm doing just to put x less than greater than, y. And then you got to put parentheses around these so they don't yell. There we go. So if we take this, we can compare if x is less than y or if x is greater than y, and it will print out true or false. So we can take this exact same thing here and replace these with string values of it. So if we run this, we are supposed to enter 6 and 9. So is 6 greater than 6 is less than 9, but 6 is not greater than 9. So that's how Boolean works. You'll get more used into Boolean once we get into if statements. Whew, my mouth is quite dry, so I'm going to take a quick break and drink some. I am back, and so what we are going to do is we are going to get rid of this operator. I'm going to just delete it because we didn't do anything in it, and I'm going to create a new class. Excuse me. New class, and we are going to create an addition quiz. And we do want to create this fish. And so, we are going to create an addition quiz that utilizes the Boolean logic that we just did. So, we are going to create two numbers, create two ints that we're going to add together. So we got int x, and x is going to be equal to, and this is typecasting right here. So what we're doing is we're just taking a long value and making it an int. I'll go over this later. Actually, right now would be a good time about typecasting. So, in Java, typecasting is when you want to turn one a variable of one type to another. So in this situation, we're turning a long to an int. It's going to lose value when it does this. When you typecast, you lose value. When you're going from a larger amount to a smaller amount, you lose data. But in this case, it's not going to matter because the numbers that we're going to be dealing with are going to be integer size. But if they weren't, then they would not be equal to each other. So we're typecasting a long to an int here, which you do by, at the very beginning, what you want to typecast, put in parentheses the type that you want to cast it as. And then this one we're doing system dot current time milliseconds modulus 10. So we'll just get a value that is under 10, which is 0 through 9. And that's what the value of x. It'll be a value 0 through 9. And then we're going to do an int y equals, we want to int typecast, if I can type from the same thing. And if I actually put it in the parentheses here. And this time, if I can actually put it in the parentheses, good lord, we're doing modulus of, we're dividing this actually, based off the example. We're going to divide this by 7 modulo 10. So we're dividing it by 7, and then we're getting a number that is 0 through 10. I mean 0 through 9, my bad, 0 through 9. Not 0 through 10, but 0 through 9. So the first operation that happens is this right here. So we get the current time in milliseconds, divide it by 7, and then find a value, modulo that to 10, so you get the ones place, pretty much. Modulo 10 is the ones place. You can get a 0 through 9 value. And then we want to bring in the scanner. So this is a neat trick. If we do SCANNER, we do Control O. No, it's Control Shift O, isn't it? What is it? Or Control Alt O. Oh, how do I... Alex, do you know how to import all the missing classes? I can't remember. It's like... to bring in all your imports. Can't remember. So scanner input equals new CA scanner S1 system dot in. So we're getting an input, and what we're going to do is I'm just going to copy this right here, because I don't want to type all this. So we're doing what is x plus y. So if we save this and run, what is 3 plus 6? And then you will input the answer, and then we'll give a output. So if I run it again, it's different every time. Nice, easy addition quiz. If you want to raise this number, whatever this number is, so let's change this one to, let's say, 20. This time it will give a number 0 through 19. So it's a little different, but Yep, see, look, 0 through 19 will be for 20. But for this example, I'm just going to keep it at 10 to keep it nice and simple. So now that we got the input, what we're going to do is we're going to get the input from the user of what they think the answer is. We're going to get an input number of the next int, and then next we're going to output whether they were correct or not. And we're going to do this based off Boolean logic. So I'll explain this. Number 1 is X. Oh, an answer we didn't ever. I was just reading, but I tried Control Shift O, but it didn't work. And Control O. Oh well. But answer we need to actually evaluate here. So we're doing X parenthesis here because we are concatenating pluses. X plus Y for our answer. Here we're putting Y. Here we're putting X, here we're putting Y, and answer is whatever the number the user put in. Actually, answer is what the user put in. So this is going to be number, not answer. So if you save this and run. So what is 4 plus 9? Anyone in chat? Alright, 13. And that is true. And let's run it again. What is 1 plus 0? Let's say you accidentally misclick and put 5. 1 plus 0 equals 5 is false. Because this right here is evaluating whatever the value of X plus Y is compared to whatever number we enter. If they're the same, the answer will be true. If they are not the same, the answer will be false. So this is a basic little check to see if things equal each other. Now, if statements. Now that we've covered basic Boolean statements, we can hop in to if statements. So let's say this right here, we want to, before we give the user false, we want to say what the correct answer is. But if they get it right, we just want to say yeah, you're true, you're right. So what we're going to do is we're going to use an if statement. If statements are just if parentheses, brackets. Personally, for me, I like my brackets on different lines. I haven't set that up yet, but this is normally how I like my brackets. Like this. So it's clearly defined. Everything between these two is a part of this right here. Everything between here is in this. It's personal preference. You can do it either way. This is the way I personally enjoy it. But if, let's say, let's copy this Boolean expression here into the if. So if this is true, then we want to say you were right. So we'll do that. Just comment this out real quick. Save it. Run. What is 3 plus 6? Let's say 9. You're right. So let's see what happens when we're wrong. So this time it worked because the if statement condition was true. So it said if this is true, which it turned out to be, It went inside these brackets, the curly braces, and ran the code that was inside of it. Now, let's say we get this wrong and put 5. Nothing happens. Because what it does is it reads this as, oh, this is false. So it skips it and goes down and runs the rest of the program, which is, for us, in this case, nothing. Say you didn't want to give any feedback when the user was right, and you only wanted to give feedback when the user was wrong. So, what we can do instead of saying when this is equal, let's say when this is not equal. You are wrong. So, when this is not equal, exclamation marks in Boolean logic are nots. So you could do it either like this is not equal to, or you could do this and surround everything in brackets and say this whole expression, take the opposite, so not it. So if this expression is true, make it false. If this expression is false, make it true. Both work the exact same. Personally, I'm going to go with the not true method here. So if we run it and we put in 7, nothing happens because it was true. What is 6 plus 0? That is 7. Oh, it went in because this value was false. This value right here became true because this right here did not equal each other. And so it entered the if statement because it was true. Only true statements cause the if to go inside. That's very important. Only true statements cause the if to go inside. There, it's brackets. And then, this is just a cheaty little simple way. If you only have one line of code that you need to run for your if statement, you can write it all inline. That's just what you can do. I wouldn't recommend it at this point, but it's just something to know if you ever come across that in a code. If there's an if and then just a line of code after it, that is the line of code that is in the brackets. It generally just saves space and it's sometimes easier to read when programming. Now, say you want this is a one-way if statement. Say you want a two-way if statement. The way a two-way if statement would work is there's this other special clause called else that you can tack on to an if. Else. So if this is true, go in this first part, else go in this bottom part. So we can just take this and put you are right. So this time we'll always get an output because there's an else. If there's an else applied to an if, you will always run the else or the if. One of the two will always run. If there is only two. You can tag on, we'll get on to tagging on more ifs in an if-else statement later on, but for now, one of these two is going to run no matter what, unless we get an error, which is not going to happen, but one of those two is going to run. So what is 3 plus 0? That is 3. You're right. Went to the else statement. What is 7 plus 8? That's 15. You're right. Went to the else. Let's see. What is 7 plus 5? Oh, that's 9. D6, apparently. Oh, you're wrong. So there's always an output for an if-else, if there is something written here. So that's how if-else statements work. And, let's see, who all do we have in chat? Not really much more information I want to cover over the stream. There's more just practice drills that I'd like people that are interested in this series to go over. So if you're watching and you're not a part of my Discord and you want more practice with this, On YouTube, if you're watching on YouTube, link will be in below for my Discord, and I will just say you want to join the Learn to Code series, and I'll get you access to all the information and practice sessions that we have. If you're watching on Twitch right now and want my Discord, I will post the link. I will post the link to my Discord in chat. That pretty much covers the basics of if statements. I mean, there's more nested and pitfalls and a bunch of different edge cases that I could cover. But for now, I think that should be fine. If you have any questions, just message me on Discord and I'll be glad to help you out in any way, shape, or form. But I don't think there's really much more to cover today. Went through that really quick. Didn't have any questions, so that's always good. But let's see what we will cover. Actually, before we go, we're going to cover logical operators. This is if you have, let's say you're wrong or you don't enter an int or something like that. It's when you use or, and not. I already covered the not as the logical operator before when we did the whole parentheses around this and put a not. That is a logical operator. There are also there are a few other logical operators. There are exclamation point, which is not. Double ampersand is an and. I don't know what these are called. I call them the long lines. It's above your backslash key, if you're wondering where that is, and caret, your caret symbol. So here's what they mean. This means not, this means and this means or, and an exclusive or. Exclusive or is where it can be one or the other, but it can't be both at the same time. That's what an exclusive or is. Like, an or is, say you have two fruits, and you can have an apple or an orange. But you could also have two apples, and that would work in an or statement, because you have an apple or an orange, you have two apples or two oranges. But an exclusive or is you can have an apple, an orange, but you can't have two apples or two oranges. You could only have one or the other at the same time, is what an exclusive or is. Not is just like, it's the opposite of what the value was. And is you have to have both. And or is you have to have one of the two. Exclusive or is you can only have the one of each type. So this is just a bunch of truth tables. I'll scroll over here real quick. See if there's anything else. If you're wondering what textbook I'm using, I can give it to you if you join my Discord. If you want to read along. It's a free textbook online I found for Java that I'm using to base the structure of my lectures off of. But that's... And let's see. See who all's here. If we're going to cover switch statements or not. I think we'll save switch statements. I may do a stream Thursday, actually. Just to cover more stuff. I'll probably do a stream Thursday to cover more loops. More conditional statements. We'll go over switch statements next time. And we will go over... We'll go over switch statements and let's see. Switch statements, and see if there's anything else. Yeah, we'll go over switch statements, and let's see. It's just a bunch of Boolean practice, which I found completely useless when I took this class. So yeah, we'll go over mathematical functions, characters, and strings next time, as well as switch statements. So that's all I have today. I will be gaming here in probably about 30 minutes if you want to come back and see what's going on with that. But for the Learn to Code series, that's all I have. I'll see y'all Thursday.